So most of what we're going to do this week is we're going to talk about uh, rigid transformations, which we studied earlier in the year, and we're going to think about what does all of that information mean when we think about it in the coordinate plane instead of just the ordinary Euclidean plane. How do having those coordinates make what we're talking about a little bit more precise? So let's pop over to GeoGebra and we'll take a look at an example for the first type of rigid transformation we thought about, which was translations. All right, so here's an example of a triangle in the Cartesian plane. And so we've got our vertices A, B, and C, and each one of them has coordinates. And so what we want to do is we want to translate that triangle by moving everything up one and to the right four. Okay, so that's a way of describing what the translation is. We can be more precise now that we're talking about coordinates because saying 1 and 4 actually makes sense. Those numbers didn't make sense when we talked about the Euclidean plane. In fact, up and right didn't really make any sense either. So we've got this figure and we've got this vector here, which is going up 1 into the right 4. And so what's going to happen when we apply that transformation to this triangle? Well, every one of these vertices is going to go up 1 point and over 4 points. So A is going to go up 1 and then over 1, 2, 3, 4. So this is going to be where A prime is. And then B prime is going to be the same. It's going to go over here somewhere. And C prime is going to go up and over 4, and it's going to be over here-ish. And then the triangle is going to be made up of those 3 shapes. Let's take a look at what that looks like when we actually do it. So we're going to translate by vector. Here's the object we want to translate, and then here's our translation vector. And it came up exactly the way that I just described it. So here's A prime, B prime, and C prime. Each one is up 1 and to the right 4. And so we can see, looking at it, that these 2 triangles are congruent. This is not a surprise. Everything is the same that we had from earlier in the year, that translations preserve distances and angle measures. So these 2 triangles are going to be congruent to each other. Okay, so that's the way translations look when we apply them. They're the easiest of the 3 rigid transformations, so I wanted to start with that one. Let's just take a quick look at what the notation is going to look like. If this notation doesn't make sense to you, go back to the previous video I made, which explains the function notation. But here's how simple it looks, that if we want to describe this translation function that goes up 1 and to the right 4, our input is going to be some coordinate points x and y. And then our output, we're just going to add 1 to the x value, which makes it go up 1, and add 4 to the y value, which makes it go to the right 4. Obviously, if you're going to go down, you would subtract that number from the x coordinate. And if you wanted to go to the left, you're going to subtract that number from the y coordinate. So that's all you need to know about how translations look in the Cartesian plane. In the next 2 videos, we'll talk about what that means for reflections and rotations.